Sham, we are live. All yours. You're on mute, Sham.
Can you hear me now?
Yeah.
Okay. Yeah, I think let's just give it a few more seconds so that people can filter in, and then we can get started.
And for those who are already here, hey guys, good morning, good afternoon, good evening.
Okay, I think it's time we can get started now. Good day, everyone. Really happy you're here with us for today's webinar. I'm Sham. I lead product and AI at Netdata, and we also have Satya. If you want to say hi, Satya, quickly.
Hey guys, I'm Satya. I'm also, uh, you know, leading product with Sham here, but also on the business side, I'm the chief business officer. So nice to have you all here.
So today's topic is going to be fleet monitoring with Netdata, and it's about how if you're running or managing or operating a distributed fleet of devices that are geographically separated and hard to reach, how you can still get real-time visibility into what's happening in your fleet and do it in a cost optimal way, in a very efficient and optimal manner overall. So some of you, I'm sure, are repeat viewers and have been on Netdata webinars in the past and are very familiar with Netdata as a product. But we also understand that there's new people joining all the time who are discovering Netdata newly. And we want to maybe spend a couple of minutes or so at the start just to give a brief intro about Netdata. So if you already know about Netdata and are a long-time user, apologies. And I hope that you'll have some patience. So for the newcomers, who is Netdata? What is Netdata? Netdata is an open source observability platform, and it can monitor practically any part of your infrastructure, whether that's an IoT device, whether it's a Raspberry Pi, to a Linux server, Windows server, Mac OS, FreeBSD, any kind of machine workstation server that you can think of, and also cloud environments, AWS, Azure, GCP, Kubernetes clusters, and all kinds of hybrid and mixed cluster scenarios that you can think of. And also, increasingly nowadays, we're seeing Netdata being used for network monitoring. So monitoring network devices like routers, firewalls, and just all kinds of devices that are connected, access points that are connected together. And Netdata does a really great job now of not just monitoring what's happening on those devices, but also showing how those devices are connected to each other, how the traffic is flowing, etc. So almost any part of your infrastructure, including the applications that are running on it, Netdata can monitor. Netdata was officially founded as a company in 2018, even though it's as an open source project, it's existed even before that. We're actually one of the most starred monitoring projects on GitHub with 80,000 stars. So we really appreciate all the love from the community when it comes to that, when it comes to how many downloads are happening per day, how many Docker pulls are happening. The numbers are truly crazy. Netdata is also a hyper scalable observability solution. So we have production deployments which go up to 100,000 nodes in a single deployment of Netdata Cloud. So we will cover some of these in the future in some of the coming slides about what makes it unique in terms of its architecture, so that it can scale to these numbers and still do a great job. And of course, Netdata also monitors all kinds of different applications and systems that we integrate with. We have 800 plus integrations out of the box. I think this number is a bit stale now. It's probably closer to 1,000, I think. And even if something's not listed in one of Netdata's integrations in the documentation, for example, since we support most of the common open protocols like open metrics, statsd, open telemetry, all of these, uh, you don't need a built-in packaged integration. You can still monitor the thing with Netdata. And our business model is based on per node pricing, and we don't charge on how many metrics or how much logs that you collect. So you can go unlimited in terms of the actual data being collected. We just monitor you on how many things you're monitoring. Netdata is also SOC 2 Type 2 certified, and Netdata can be run entirely on your premises if you have those sort of data privacy requirements. And also, something interesting is there was a research that was done by University of Amsterdam. It's completely independent, not sponsored by Netdata, and they found that Netdata was the most energy efficient monitoring agent that they tested and sampled, and they covered most of the common popular monitoring agents out there. So this is nice for us to hear. We were surprised. We didn't know this research was happening, so it was a pretty fun thing to hear about. So that was a quick intro, and let's get into the webinar proper now. So today's topic is about distributed fleets. So what is a fleet of devices? What is a distributed fleet, right? So you can think of a lot of different use cases which fit into this. We'll just cover some of them. So it's basically it's fundamentally different to your data center style infrastructure, where you have a group of servers in a lab in a data center somewhere, and you have people who are you know administering them, operating them, making sure they're running, making sure they have all the love and care that they need to make sure that everything is operating well. And on the other hand, you have these distributed fleets where it's not infrastructure that you can walk up to. It's distributed all over the place. Maybe you have customers all over the country, multiple countries sometimes. And once you ship the device out to the customer, you might never see it again. Hopefully, you don't have to see it again because it's working well. So the underlying requirements are very different from monitoring something like a data center or a cloud environment, for example. Um, there are some examples on the screen here where, for example, in the retail side of things, you could have a network of stores, and each store has point of sale terminals, and there's thousands of these things. They're spread across different stores. Every store is in a different network, and it's not a very expensive device. So it's not like you're going to be able to send engineers on site to fix every small issue that pops up on these devices. So it's crucial that you have the understanding that from a single central place on your side of things, as the person or the team who's in charge of managing all these devices, you're able to identify issues, preempt issues ideally, and gonna get to the root cause faster, right? Because these devices itself might be low cost or low powered, and there's many of them. But if they actually go down, the impact it has to your client or your end customer or whoever is using these devices is quite high. Especially in a store, if the point of sale system doesn't work, it has all sorts of repercussions, obviously. Another increasingly common use case that we see nowadays is a distributed robot fleet. And there's all kinds of different robots. There's robots that work in these factories, in industrial environments. There's robots that are deployed in sort of people's homes and consumer facing places like supermarkets and so on. There's specialized robots. Obviously there's autonomous driving vehicles, which are also robots of a kind. So you have all these different kinds of robots. They're usually more, let's say, each individual robot is more expensive than something like a IoT node or a point of sale terminal, but they're still distributed. They're all over the place, interacting with the real world. And you don't have full control over it. You don't have full control as the, let's say, the company that makes, manufactures, and operates these robots. You don't always have control over which network it's connected to, how the connectivity is. And again, it's not always possible to have engineers on the site. And something that's common across all kinds of different distributed fleets is the fact that things can go offline at any point in time. Network blips do happen. And also, there are certain, let's say, pain points or limitations when it comes to these sort of distributed fleet environments that we'll touch upon later, that are unique, especially when compared to the data center side of things. There's also, we've had customers and users from all kinds of different industries when it comes to this use case or this niche, including industrial IoT. EV chargers is a common use case, but also you can get some use cases on the telco side which kind of fit into the space. And then you have biomedical devices, online kiosks, autonomous vehicles, and many more. So let's get straight into the problems that you see and why monitoring fleets of this kind cause problems for traditional monitoring. And by traditional monitoring, what I mean is either centralized monitoring, where all of the data is always being collected into a central place, into a central server somewhere, either on your own premises or on the cloud somewhere, where all the monitoring data exists in one place. Also, you have your legacy monitoring solutions, which I'm sure many of you would have used and tried in the past. So the old way of monitoring has certain, let's say, core criteria, right? One of them, obviously, which we hear a lot, is um, kind of volumetric pricing in terms of how much data is being monitored. So you might see things like, you monitor X amount of logs, X GB of logs. There's a cost associated to that. Then it's metered cost depending on how many terabytes or gigabytes of logs you're monitoring. Similarly, for things like synthetic checks, uh, metrics as well, how many time series you have, and the more you have, the more you have to pay for it. What ends up happening is that customers usually decide that it's not cost effective for us to monitor everything because it's so expensive. So let's pick and choose, let's cherry pick what we need, right? So we say that maybe we just need these 10 metrics, maybe we need these 25 metrics, and we live with it. And if and when we find out something, we might add or change some metrics. The problem with that approach is that you can't anticipate what happens in the real world. There's all kinds of crazy things that could go wrong. And what usually ends up happening is that you hit an issue, you hit an incident, and then you do a post-mortem, and then you say that, okay, to prevent this sort of issue, we should be monitoring X, Y, and Z. So let's add that to the monitoring stack. And you add those three metrics. And then a few weeks later, you hit another issue, which is different from the previous one. So you say, oh, to catch this issue, we should have been monitoring A, B, and C. So let's add that. And this sort of rigmarole, keeps on going. We've all seen it in different companies in different environments all the time. Netdata's approach to this is fundamentally different. Our approach is that you should collect all the data, everything that you can, every metric that Netdata can see, we will collect, we will store it, and you can visualize it. Same thing goes for logs, same thing goes for anything else that we are collecting. Let's just get everything. We're not going to charge you for how much you're monitoring. So you don't have to worry about that cost angle of this. And we will, on our side, make sure that we're doing everything that we can so that this huge amount of volume of data can be understood, it can be processed, it can be understood, and it can be optimally visualized for you on the screen. And a big part of how we do this is by distributing the data collection and the processing. So the processing can also happen at the edge. You don't need to ship anything on on a metered connection until necessary. The other point here is, of course, like I mentioned earlier, the connection is not owned by you. So the network is not owned by you. Links can drop at any time, and you should still have the ability to go back at a later point in time and see what happened during that time, or the end user should have a way to understand what's happening right now, even if the internet connectivity has gone down. So this is another area where Netdata, since it's distributing the monitoring into individual nodes, has the ability that even if the overall connectivity is off, you still have a way to get access locally to the data. And we also have, let's say, which we'll come to, the architecture has these mini centralization points, which means that you can offload the data from one node to another node, so that when this node goes down, a parent node still knows, all the data that happened until an individual node goes down. And this is useful for high availability, for ensuring that the data is always there when you need it. And the other things are, of course, you don't have uh, hands on the site. Like I mentioned, there's no engineer who's traveling to each store and debugging issues, or each factory site. So you need something that's low maintenance and low on the configuration burden. You want to ideally install it and forget it, and just be aware of it when there's things for you to do. And you need something that's architected for distributed environments. You can't take a tool that was built for a centralized environment and then massage it to work for a distributed fleet. Uh, that way is leading to all kinds of problems. So the net effect of all of this is that the bigger the fleet, so 100 nodes, 1,000 nodes, 10,000 nodes, the bigger the fleet you have, the wider the gap between these two different kinds of monitoring becomes. So Netdata's approach to this is, um, it's very different from what you'd see with regular monitoring and the old traditional observability pipeline. The data is processed on the node it comes from. You, as the user, can specifically choose where the data is collected and stored, where the data processing happens. So you can choose, instead of saying everything happens in one place, you can say, for this node, it's strong enough in terms of resources, let the data processing happen there. But for this other node, maybe it's an IoT node and it doesn't have a lot of resources, it can just stream the data to another node who will process the data for you. So you have full transparency and full control of how this happens. And in terms of data resolution, of course, Netdata is known for being real-time monitoring tool. And when we say real-time, we mean every metric is monitored every second. So you don't have to do averaging out or sampling unless you really need to. And in terms of the data transfer, if you have a centralized tool, especially one that's shipping the data to a cloud somewhere, what happens is that you have lots of data constantly being sent somewhere else outside your network. So the amount of data egress that happens is quite high, which almost immediately rules it out for many of these distributed fleet scenarios. With Netdata, the data is only queried on demand when you need it. And what that means, we can show you during the demo, is that when somebody is looking at the browser, at a dashboard, and looking at a few charts or looking at logs or metrics or anything else, only the data that's on their viewport, on their screen, is being queried in real time. And if they close the browser, that's it. There's no more querying happening unless an alert is being triggered somewhere. So we're talking about, orders of magnitude difference in terms of the actual amount of data being streamed out of your network.
Yeah, I think, Sham, this may be a good, although you're in the middle of the slide. We
Sure.
had a question from Jose, which said, please go into how secure our data would be. So just to reiterate what Sham mentioned, Jose, so the data is not stored by Netdata. So it's not on, even though you're using our SaaS solution, it's just the control plane. The data will remain within your infrastructure or within these distributed fleet devices themselves. So you are not sending the data anywhere else for you to be worried about data privacy and security. That's the uniqueness of our distributed architecture. I hope that answers that. But if you want to add to it, Sham.
No, I think you answered that quite well. It's kind of related to the next point that I was coming to. So when you see traditional observability solutions and how they handle things like anomaly detection or machine learning, where they have to train these models, again, all of it happens on their cloud or on their data center, which means they're collecting all of this data, storing it for you, and then they can do all kinds of cool analytics on top of it. Our approach is, as Satya mentioned, it's different. So the data is stored, it remains within the customer's premises. And for something like machine learning, again, this happens at the edge on the device. So it can happen on every individual agent, or you have the flexibility, like I mentioned earlier. You could say that I have 10,000 devices. I don't want all of these running machine learning. I have these 20 servers here, which have extra resources allocated to them. Let these 20 servers take care of running machine learning and alerting and all the data processing for everybody else. So you have the flexibility to do that. But once that happens, again, it's happening on your side of the network, on your premises, and we're not taking that data out anywhere. It's the training, the data collection, the inference, everything happens on your side. And this is the main reason why we are able to keep the costs significantly down compared to the centralized solutions, which have to charge you based on the amount of data, because they are sending all that data out all the time. They have to store all that data on their cloud. So there is a direct correlation for them in terms of the actual data volume. Whereas for us, there is a correlation for the metadata and how much, let's say, cloud operations are required to keep the control plane side of things running. But we don't pass that on to the user. You get a flat per node price, and the more nodes you have, you get volume discounts coming in as well. So if you have thousands of nodes, then your per node price is a very fractional amount. So the underlying idea here is that the fleet is monitoring itself. The fleet has the agents, Netdata agents running on it. So each individual node, or multiple nodes being monitored by one parent agent, all of that is happening on your side of the world. And when you interact with Netdata Cloud, which is our control plane, you're seeing what's happening there. You're not actually seeing something that's happening on Netdata Cloud being stored on Netdata Cloud. So that brings us to the architecture which we've been talking about. So we're trying to, let's say, visualize this in these three different verticals. On the left here, you have the edge, which is your premises, your fleets. So this could be uh, Netdata agents running on in stores like point of sale systems, kiosks, workstations, and things like that. It could be vehicles, it could be robots, it could be telematics devices, it could be gateways and industrial systems, IoT, all kinds of different environments. You can have Netdata agents running on them directly. You can also monitor things remotely using Netdata. For example, if you have a number of network routers and switches and access points, you don't need to install the Netdata agent on them. You can remotely monitor them using Netdata. But for any node that you are monitoring using an agent, you can you can see the default resource utilization there below. So it's less than 5% of CPU on a single core, 150 MB of RAM, and like I mentioned earlier, it can work offline as well. It doesn't need a live internet connection. And these are just the default resource utilization limits. They're configurable, so you can choose which metrics you need if you want to do that. Though ideally we want you to collect everything, so because you never know what you'd need. And these are your, let's say, individual Netdata agents and nodes. We call them child nodes or children. And they can stream data to what we call Netdata parents, which are just other Netdata agents. It's the same piece of software. It just has extra configuration which says that your job is not just to store your data, but also the data of your children, which are these other nodes specifically. So the concept of Netdata parents allows you to have highly available clusters. You can have long-term retention for all these other nodes. So your Netdata parent nodes, for example, could be provisioned with more disk space than the other nodes, more RAM, more CPU, and you can have years worth of data being stored there. And it also helps you offload some of the data processing, things like the machine learning for anomaly detection, the alert checks that happen. All of that could be offloaded to the parents so that the child agents can run super light. They're just streaming the data to the parents, and everything happens at the parents. Or it can be a mix and match. It's really up to you and your unique requirements. And
I
then,
think, Shah, there
yep,
is a related question which
sure.
comes in from Joe. It's about what is the resource increase for nodes being monitored? I think you have it there on the left side for the fleet. It's definitely less than 5% CPU. I think 150 megs is probably a typo, but it may be for a full-fledged system. For distributed fleets, it's anywhere between 10 to 15 megs of RAM, which is what some of our customers are running it on. And like Sham mentioned, the University of Amsterdam, in their research, actually identified that we are the most energy efficient solution when it comes
Yeah.
to observability. So it does
So,
run with
so
very,
yeah.
very
So
minimal
some of the
overhead.
numbers that you might see here and on our documentation are for standard Linux server monitoring kind of use case. For fleets, like Satya mentioned, you would be making some optimizations to the Netdata configuration, which would bring down these resource utilization again by potentially an order of magnitude. And then, on the third vertical here, you have our control plane, which is Netdata Cloud, uh, where we do not store any raw data. Only metadata is stored here. And data just flows from the edge of your fleet through your Netdata parents, through Netdata Cloud onto your web browser, where you're seeing Netdata dashboard. Netdata Cloud also brings with it the capability to see a unified dashboard across all of your thousands of devices. And of course, features like role based access control, single sign on, AI troubleshooting, all of that is built into Netdata Cloud. You can have what we call spaces, which are per team. Within a space, you can have rooms which are specific to different groups of nodes. If you've used a tool like Slack, for example, you can think of rooms almost like channels, where in a Slack channel, you could have different channels where the same person exists with a different group of people. Similarly, in data, you have rooms, and the same node can exist in different rooms with a different group of nodes depending on you know the need that you have. So again, the raw telemetry is always stored on your fleet. So this is just a quick snapshot from some numbers that we've collected across case studies, some of which are visible on our website in the case studies section. But it's about different kinds of fleets, right? So we have IoT fleets where thousands of devices are kind of distributed across different stores, and their entire fleet is being maintained by one person using Netdata, and he's quite happy with Netdata and the fact that he's able to manage all these thousands of devices in a very optimal way. There's use cases related to autonomous vehicles where Netdata has helped them identify uh, root causes much faster than they were in the past. And of course, there's robotics use cases where we've been able to lower the monitoring cost significantly. There's school security use cases where there's a huge number of devices that are distributed across schools, across the country, and all of them being monitored from a single place by a small team. And yeah, there's we've just taken a sampling of use cases here. I don't want to go into the details of each of them, but yeah, if you check out our case studies on the website, you can read more about them. But the key point is that there's very different kinds of use cases, which are all still distributed fleets of some sort or the other, and some, they share a set of common pain points where Netdata can help. Okay, I think it's enough of me talking. It's time for a live demo. So, Satya, over to you.
Okay, let me quickly. Okay. Okay. I hope my screen is visible now. Thanks, Sham, for the great introduction. I think we also covered a few questions, but then we thought um, it's good to also show you what a customer with a distributed fleet will potentially see on the dashboard, what kind of signals are important, and how do you actually create useful views for different teams. This could be the NOC team, it could be the level one support team, but also maybe executives who want to look at how the fleet is running. So what we did for the sake of this webinar is we created a simulated distributed fleet with over, uh, I think, exactly 1,000 devices. Uh, they are distributed all over the globe, and they are trying to simulate. It could be potentially a robot, a kiosk system, or even certain gateways that are positioned in different customer environments. So as you can see, okay, let me go to the specific room, and I'm not going to do a full deep dive of the dashboard. I think that may be for a later time. But as you can see, a very high level, once you deploy Netdata into these distributed fleets, and it's just a single command that you run once the fleet is up. For many of our customers, they have it embedded into the operating system of the fleet, some kind of an IoT device. But the agent is installed on the fleet, like Sham mentioned. They have some kind of centralization implemented, so they have some high availability. So in case one of the gateways or the robot goes down, you don't lose that data. You have the ability to debug what happened, even when the device itself is down. So we've created a very similar environment. As you can see, we have about 1,000 devices with one single centralization point, which is a parent. So even if you have a huge fleet of hundreds of thousands of devices, you don't need too much IT infrastructure to be monitoring them. It could be a bunch of servers or VMs. And as you can see, we are collecting about 540K or 500,000 metrics coming in uh, every second. A bunch of charts that are automatically visualized, so you don't need to put together your dashboards. Netdata does that for you, and also a whole set of alerts that are pre-configured. Now this is just the summary screen, but what you have is the ability to group the
And
nodes.
you can also see here that there's 1,000 children and one parent. So in this simulation, we just have one Netdata parent that all the children are connected to.
Yeah, thanks, Sham. So if I wanted to look at this based on some grouping, so let's say we have embedded certain host labels into the fleet. So in this case, I see EU Central, US East, US West, and a grouped view of how many gateways there are, how many of them are healthy, but also are there any active alerts in any of these regions. Currently, I don't see too many active alerts. I just see three critical ones. We'll get into those as we go further into the demo. So if we go into the nodes tab, it's going to show you the entire fleet. as a list. Let's just give it a bit to load. Okay, I have certain filters, but if I remove those, so all of the, let's say, 1,000 robots or gateways are available. And if I were to click on any of those, we have a bunch of metrics that are being collected automatically by the Netdata agent. And they're only being queried now that we are visualizing this on the dashboard. And what we've also done is created, no, I think I opened the wrong gateway. So for each of these gateways, we've created some custom metrics. And I think this is pretty common for such a distributed fleet environment. So one of it is to check the uplink. So for most of these devices, you have some kind of a network. It could be Ethernet or some other kind of network, but also a backup mechanism, which will be cellular. So this is the ability to view if a gateway or a robot is running in cellular mode or an Ethernet mode. There is a health score. So if we have certain ways of identifying if the device itself is healthy, that can be visualized as a metric. We have created a Prometheus exporter for this, but we could have a very simple shell script doing this, which is a Netdata plugin. And the other one is if it is running on cellular, how is the connection stability, right? Are we using too much bandwidth? Because sometimes these can be expensive, depending on what kind of cellular plans that you are on. These can be really expensive, so it's imperative for customers to know what's happening with their fleet in terms of what network it's running on and whether the network is stable. So we've created some custom metrics, as you can see, but you can
So
also visualize
just
this.
to add, Satya, the idea is
Go
that
ahead.
it's not just the system level metrics and the built-in applications that Netdata is monitoring. You might have your own custom metric, your business metrics running on these devices, uh, with a very simple shell script, or if there is already an exporter for it, you can grab those metrics and put them into Netdata as well. So you can correlate between your actual business function metrics from your devices and your system level metrics. Sorry, go ahead, Satya.
No, thanks, Sham. Thanks for chipping in. So, so one is, of course, right, you can go into individual devices and look at what's happening, but we also have a fully aggregated view and what we call a metrics explorer. So, for example, I don't want to go into each of these devices, I just want to look at what's happening at the fleet level. So this is the total CPU utilization across all of the 1,000 nodes. And if I change the grouping to per node, what you will see is the CPU utilization on each of these robots or gateways. It just takes a while because 1,000 nodes is quite a bit. But yeah, as you can see, it's showing you the CPU utilization. Since it's a simulated environment, most of them have similar data. But let's say, let me sort this. And if I were to click on any of these individual devices, I get to see how the CPU utilization is varying over a period of time. So you have a single pane of glass to look at all of the data that's interesting to you. Now, of course, this webinar is not about showing, hey, what all metrics, what all different capabilities we have within the data, but more on how do you actually look at the entire fleet and the signals that are important to you. And this may not just be relevant to distributed fleets, it's also perfectly relevant to IT infrastructure and when you monitor. So we always had this nodes tab, which is a list of nodes. You put a bunch of key metrics that are important to you and visualize them over a period of time. But what we realized is we can do something much better, something that's more useful. And hence we added, so first of all, you can add all the data points, all the signals that are important to you. So this acts as a data source. So for example, I go into columns, I define what columns, what labels, what metrics are important for me to be able to monitor this fleet. You can also set up some settings for the grouping. So assuming right now we are grouping by region, and in the group settings, I want to say, hey, for each region, I also want to see what's the total of something, or what's the average of something, or what's the percentile, minimum, maximum. You can also define those. So once you do that on each of these groups, let me try and minimize this. You will also be able to see the aggregated data. I've only done this for these three metrics right now, but you can also see the aggregated data, but also on each individual device, what are the most significant signals. But the magic is when you want to visualize all of this in one single screen. So let's say I move this to the map view with the same grouping, which is, hey, let me group this by region. And I think for the sake of this screen specifically, let me switch to the light mode. I think colors are more evident in there. Okay, let me first expand all groups. So now we have the map view grouped by region. You can define a fill color. So each of these hexagons is actually one gateway, one robot, or anything that's relevant to your fleet or your IT infrastructure. Whatever you have defined in the data source, which was the table view, you can use any of those data sources to say, hey, I want to look at this, or I want to look at something else. So in this case, I've used the fleet health metric that we had created. And I want to say for the coloring, if the fleet health is less than 80, it's a warning. If the fleet health is less than 70, it's a critical. So the colors that you see here for each of the gateway indicates the health of these individual devices. So if you had a knock team or a level 1 support team, and you want to very quickly see, hey, what's happening to my systems, just look at the red ones, and you know that the health on these devices are not good. And when you click on them, oops, you get a high level view of, hey, what's the health? So the health score was from 0 to 100. It's 65.6. Are there any alerts? So it's currently in clear state. But you also see all of the data that you have defined in the data source. So what's the connectivity? It's on Ethernet mode. What's the health score? What's the CPU usage, memory usage? So all the important signals that you may need to see is right there. And you can choose different signals here. So instead of health, you can say, hey, I want to look at this based on uplink or maybe something else. But also, let me flip the grouping. We've tried to mock, let's say you have multiple clients. So yeah, it calls it client A, client B. It looks a little monotonous, but for the sake of this webinar, so assuming you have a different grouping and you want to look at, hey, what's happening from a client per customer perspective, you can very easily look at this.
So this could be a sort of multi-tenant scenario where you have different end clients and customers. These could be shops, these could be sites, these could be different locations, different cities. It could be anything depending on your individual use case.
Absolutely, absolutely. But not only can you visualize everything in one screen, you can also filter this down. So let's say I want to look at only the devices whose health varies from, let's say, 60 or let's say 40 to 70. And this now becomes a filter. So you have 198 devices that actually have, let's say, a lower health. So if your team wants to focus on just certain devices with a certain signal that is important, you have this right away. So if you click on any of these, it gives you the details, what gateway this is, the actual signals and their values, also how it has been varying over time, and all of the data. But also, for example, if you want to search for a specific device, you can start typing and it'll start showing you which devices match. So let me look at, let's say, gateway 12 or gateway 11. So as you can see, there are 8 devices that kind of match a certain thing. It is highlighted in here. There's an edge gateway 11. And if I look at it, it's going to give you all of that data, right? So you can basically attach a border color. So in this case, I've set it to an alert status, but this could be another signal altogether. So for example, if I want this to be the uplink, whether it's cellular uh, or Ethernet, so I can say higher is worse, because in this case, if the value of that metric is 1, it means it's cellular. And I can say the critical value is actually 1. So you can use 2 data points at this moment. One is the fill color, the color that is within the hexagon, one that is the color around the hexagon, to indicate different signals. This could be alerts, this could be the node state, it could be any metric, any signal that you want to visualize. And then you can also further filter this down. Say, hey, any systems with a health of this, or maybe give me only the systems that are running on cellular mode, for example. So now this is going to further filter it down, I'm assuming. So instead of 198 devices, you have 43 devices which are on cellular mode and have a moderate health score or a low health score. So you can focus just on those. And once you do this, you have the ability to save this view, save all of these filters. Uh, Go in here. Let me say save current view, give it a name, and share it with everyone in your account, in your room. If I did that, so you basically have all of your different views. So your teams, depending on what they're looking at, can have multiple views. You can also create multiple groups. So in this case, I just created one data source, but you could have multiple data sources, depending on region, depending on any other host label, and have different views for them. Let me pause for a bit. It might be a bit much, especially if this is your first interaction with Netdata. And let me see if there are any questions. I don't know, Sham, if you have seen any questions.
I don't. I haven't seen any questions so far. But yeah, this was a really nice demo, and I think it's some nice flashing colors on Netdata for everybody to enjoy. So
Yeah, I think I'll switch back to the dark mode, which is what I prefer. Uh, Last
and
couple of topics that I want to cover.
sure, and I think maybe again more intended for the newcomers. You could also show an AI investigation report just so
Exactly.
they understand. Yeah, that
Exactly what I
you
was
can
planning.
deep dive into things manually like this, but you don't have to. You can use it when you need it.
Yeah, exactly. So we have our AI insights, which basically has access to the anomaly advisor, metrics correlation, a bunch of tools that, you know, as even humans, we use naturally while troubleshooting issues. So it has the intelligence. You can trigger a new investigation, which is a completely custom investigation on something that you want to report on. I have just created one before this webinar started. It takes about a couple of minutes. So my prompt was, can you find the gateways/robots that have degraded health and try and identify any correlations for their degraded health? It did find some of these within the tool. So as you can see, it says, hey, this cache O1 has a few alerts. It has degraded health state. but it does give you a bunch of things. I don't think this was even a very good prompt, truth be told. I haven't given it context. I haven't told it a timeline of when I wanted to investigate on. But still, I think it's looking at the fleet wide anomalies. It's looking at if there are any anomalies that happened during this time frame. It also looked at the percentage of anomaly dimensions. Let's see if it has any recommendations. So it does say, hey, there is some CPU utilization uh, between 9 to 11, it has no pressure. Resource exhaustion, it says there is no evidence. But truth be told, like I mentioned, it was just a very, very high level kind of a prompt I gave. And I don't think it's figured out something that you need to worry about. So it does
Yeah, but
briefly
yeah, the
mention
the
that.
idea is that you might have 1,000, you might have 10,000 devices, but you can always come here and ask a simple question, and Netdata AI would kind of do that grunt work for you, right? Going through all of the metrics and the logs to identify things that then you might want to further deep dive on the node view that Satya was showing, right?
Yeah, absolutely. I mean, you may not even need to create a report. You just want to chat with Netdata and ask for certain details. Hey, what active alerts are triggered? Anything important?
By the way, Satya, I think there are a couple of questions. If you can pull those up.
Yeah, I don't think I can put them on this stream.
Okay,
Unfortunately,
so
this was a custom stream.
I think the first question was about, can these be automated in any way if an anomaly or alert triggers? I'm assuming it's about the investigation.
Yes. So
So
go ahead, Sham. I think you are the perfect guy to
yeah,
respond to
so
that.
so we have different kinds of reports. So you can schedule investigation reports so that they happen periodically. So they could be looking for example, an anomaly analysis report is something that you could schedule to run once a day or once a week. Its job would be to check if there's something out of the ordinary happening. If nothing happens, it's fine. It'll say that, I haven't found anything worth alerting about. But if it does find something, then it will also highlight that in that report and send it to you. Currently, we don't schedule alert investigations automatically, primarily because we want to avoid noise. You might be getting alerts due to misconfigured alerts, for example, um, and we don't want to trigger investigations for each of those things. But it's really easy. If you have an alert trigger that happens, you get an alert notification by email, by whatever other channel, and there's a troubleshoot button on it. You just need to click, so it's one click away, and then the report runs in the background, and then you get an email again with the summary of the report.
Yeah, but I think some of our customers have actually automated this to an extent. Some of these AI insights, but most of the functionality of Netdata is accessible by APIs. So some of our customers have actually said, hey, if I receive an alert notification, trigger an API that actually
Yep.
investigates. There is some customization possible. For now, like Sham mentioned, this is more intended to be a reactive diagnostic tool, but we're also working on what we call the Netdata Co-SRE, which is precisely the capability I think you're looking for. So it will perform some checks at regular intervals, figure out if something is wrong, trigger reports, identify issues even before they become real outages. That's precisely where we are going towards.
I think there's another question. It's, when you limit the metrics in your dashboard for the nodes you are looking at, can you tell those nodes to only send the information you're looking for, or is the filtering just within the dashboard?
No, you have the ability to do both. So at collection time, you get to define what kind of metrics you want to collect, but you may actually collect everything, but you can choose what is a subset of metrics that you want to stream. We were talking about this Netdata parent or the centralization point, but also on the dashboard, you can filter out to say, hey, I only want to look at this. So you have
And again,
multiple levels at
I,
which
I
you can filter.
yeah, I think when you filter, when you apply a filter on the dashboard, what's happening in the background is not that all the data is still coming and then you're just throwing away the data you don't want to visualize. When you apply a filter, that changes the query that happens in the background. So if you're filtering out certain things, then Netdata Cloud does not query for it at all. So only the thing that you're actually filtered on is queried.
Yeah, thanks for those questions. I think, Sham, we are approaching the end of the
Yeah,
hour, so maybe you should take over and summarize and conclude. Unless there are any more
sure.
questions that are coming in, feel free to pour them in.
Yeah, I think thanks for that very detailed demo, Satya, and thanks everyone for the questions. I'm sure you will have more questions once you uh, sit with this for a little while. Please feel free to reach out to us. You can hop on our Discord or just send us an email on product@netdata.cloud. We'd be happy to help you out. If there's specific questions that you have, we can even jump on a call if need be. And here are some links for the newcomers, just to kind of get you started with. So if you want to create a free account on Netdata, just go to app.netdata.cloud. You can sign up for free. You get a 2-week free trial with all the features enabled. So you can just try out everything that you need. After the 2 weeks are up, you would get downgraded to a community plan, where you can still monitor up to 5 nodes without any other limits. Um, you can find our documentation on learn.netdata.cloud. There's also an AI agent on the site, which is not just for having conversations, but you can even assign it some work to do. For example, if you're trying to build your own custom collector using Netdata, you can use the AI agent on learn.netdata.cloud as sort of a pair programmer to help you through what you're doing. And of course, you can find us on GitHub on netdata/netdata. Please check us out. Um, if you have any specific requests on features and things like that, please open a feature request on GitHub. We will be keeping a sharp eye on it. I think that's all from me. Unless there are any more questions from anybody, I think we're just about in time. Uh, Thank you, everyone. I hope you
Thank you,
all have a
guys.
great rest of the day and rest of the week. Thank you.
Thank you. Bye bye.